right?
Hey Alex,
Yes.
can you write with black ink, please?
Oh, black ink? Yeah, sure. So this is 50, 20, and 5. Okay. How many 50 cents can I use? At most one. So I'm stuck with 50 cents plus X and allowed to use only 20, 10, and 5. Okay, once again, now it becomes a little trickier. Now you have to branch, right? Because out of these 50, you can give either one or so you can have, okay, you can use at most two, right? At most two of them. So if you use at most two, you will be having at least 30 cents plus X to be given with 10 and 5. And lo and behold, you can use only one 10-cent coin. Did I mess up something? Yes, so 220. I could do, after I'm 50 plus X, I have possibility to either use one of 20, or I have possibility to use two of them, so it will be 10 plus X if I use, so this is if I use 2 times 20, right? But now what is the problem? Can I use a 10-cent coin now to give this 10 plus X?
No, because then you can swap it.
Exactly. Because I use 2 times 20, if I would use 10, I could swap these for 1 times 50. So I'm not allowed to use these 10, and I end up with what? With the 10 plus X to be given in 5-cent coins, and clearly things break down there. Because I can use at most 1 5, and I end up with 5 plus X. Well, 10 plus X without using 10, so this is obviously suboptimal. And if I gave only 120, I end up with 30 plus X, but I cannot use more than 2 10-cent coins, so I will end up with 10 plus X with 5-cent coins, and again I'm stuck because I can use only 1 5 to give 10 plus X, and it clearly leaves me leaves me with a suboptimal solution. So you see, so that's an example in which you don't really massage a non-greedy solution into a greedy solution, but because of the uniqueness solution, you show that if greedy is violated, that's it. You cannot fix it into a optimal solution no matter what. So the only correct way to do it is to do it with greedy. Okay, let's do another greedy, and then tomorrow we will do only polynomials and okay, so another greedy is this. You have bulletin boards, right? And you have to put flyers on a bulletin board. So if you look from above, what does it look like? Let's see. From above, this is your bulletin board. Right? Here it is. And here are your flyers. Here is one, another one, and here, and maybe here. People just keep piling them up. And you want to use minimal number of pins All these problems will be on the problem set that I'm going to post on the web page either probably tomorrow, okay? So this is your bulletin board, and you want to use minimal number of pins to stop these pliers so they all hold onto the board. How would you do it in an optimal way? How would you start them all to fix them to the board with the minimal number of pins?
Just as a random guess, you'd start with the most overlaps first.
Okay, so here is something that sounds very appealing. What you would do,
So wrong.
you you see, but that's a whole point of the exercise. The whole point is, that's the difference for taking and not taking this course. One of the main benefits of this course is for you to avoid being lured by kind of natural solutions, but that they happen not to be optimal, right? And you know what Google does on job interviews. At least a couple of times I heard it from a former student of mine. They give you a problem that is an open problem. No one knows how to solve it. They ask you to solve the problem. What do you think? Why are they doing that? And what is your good answer? You are not familiar with the problem. You don't know that the problem is hard and open. And you try to solve it on the spot. What do you think? What's a good outcome of this interview and what's a bad outcome?
You showed you proved that it's not.
Then you get a Nobel Prize and you don't have to work. So what do you think? What if you did well? If you tell them what? I don't know how to do it. What they are looking for, are you going to propose something silly that with a little bit of thought clearly doesn't work? So they want to see whether you kind of try to do things uncritically in an easy way, right? So if it looks hard, don't try to kind of fudge a solution because maybe there isn't one. You simply tell them, gee, I cannot solve it at the moment. So, and the whole, this is the whole business, and you will see more and more when we do dynamic programming, that in fact the whole business is that, this is why we have techniques like greedy, which is the simplest one, or dynamic programming that allows you to solve hard problems in an efficient way, right? So that's the point of you taking this class, right? And one thing on the final and on the midterm, I have to tell you that. You get 0 points only in case if you propose a brute force solution. Because what do you think, why are you taking this class if what you come up is a brute force solution, for crying it out loud, right? So, you know, even if you fail, if your solution doesn't quite work, but it makes sense, but just you get partial credit, but don't do, you know, don't try to hack it with a brute force. Okay, so here is an example why this does not work. So it's very appealing to look for the place where most of them overlap, because it looks as if that there are as few as possible now to take care of. But let's consider a situation that looks like, say, this. And then, say here, like this, and then here, like that. Okay, so where would you start if you did it with this intuition? So So let's see here, there are 4 overlaps. This is 1, 2, 3, 4, 5, and this is 3, so you would put a needle here. Right? But now look, this guy hasn't been stabbed. So you will need 1 needle here, and this guy hasn't been stabbed, so you will need another needle here. So altogether that's 3 needles. And clearly, you can do it with only 2 needles if you put a needle here and a needle here. Essentially, the reason why stabbing at the densest place is not a good idea, because it can turn out to be superfluous due to the needs to stab at other places. So you might simply not need to put a needle there. So what would be then a wet and greedy criterion?
You get the pin, and then you start from either side. You keep going until the very last point to put the pin in.
Very good. So that's, you see, every flyer has to be stabbed. So look for the flyer that ends first. This flyer has to be stabbed. What is the most economic? So there has to be a needle to the left or at that point. When is the most economic to put the needle? At the very end, because this guy has to be stabbed, so we will stab it as late as possible in order to catch as many of them as possible. But there must be a needle between the beginning of the flyer that ends first and its end. Right? So I'll let you argue for yourself to show that this is in fact optimal solution. Okay, so let's just do another quick one, 2 minutes. You remember on your assignment you had this business with a road, right? And houses. Okay? And you were asked to put minimal number of base stations. Okay?
So you need to recap on that previous one. What was the...
So the strategy says, start from left to right, look for the earliest end of a flyer, and start it there. Then forget about all start flyers. Again, among the remaining flyer, looks for the one that ends the earliest. Start there and keep doing that way. Okay? I guess we are out of time. Okay, so we will then continue tomorrow.